Welcome to another night of Emerald Hill skies. My name is Doug, and we're coming to you tonight from the outskirts of Louisville, Kentucky. And we operate from this observatory. It is a Pier-Tech Tele-Station 2 roll-off roof observatory. And you can see there in the middle, that RASA 11-inch telescope is mounted on top of an iOptron CEM70G mount, and it sits on that adjustable height Pier-Tech pier that you can see there in the middle. And we're really fortunate to have, by God's grace, a bunch of neat little gizmos that with it. This is the all-sky camera that you'll be seeing tonight. It's a ZWO ASI2600MC Pro monochrome camera. And you can see a couple of Pegasus Astro products there, the power box and the USB distributor. You can also see this rack at the base of that adjustable height pier. This contains the power supplies, power distribution hubs, a rig runner power distribution box. It contains the USB transport device that runs our signal over the 200 and some feet fiber optic cable from the observatory to the inside of this building where I'm sitting, about 200 and some feet away, so we can observe in the nice air conditioning out of the mosquitoes and all. That camera on the end of that RASA 11, it's a Celestron RASA 11, is a ZWO ASI2600MC Pro, and it's a color camera. It's mounted there on that. You can perhaps see that that red camera is attached to a camera interface made by Octopi-Astro, and that tunes the camera so that we can reduce the amount of tilt and make sure it's aligned correctly with the Celestron Rowe-Ackerman-Schmidt astrograph. As I said, my name's Doug. Let's dive right in tonight. I thought maybe what we ought to try to do is just look tonight at this view of this part of the sky. And this is often called NGC 7317. It's also sometimes nicknamed Stefan's Quintet. And what is interesting about this part of the sky is that there are 5 or so galaxies that can be seen close together. Now we're zoomed in at about 100% of our camera's capability. Now I don't know if you can see at just 4 minutes of time, you can already see some nebulosity here around these fuzzy little objects. And these fuzzy little objects are faint little galaxies that are barely detectable by our 11-inch telescope. I'll zoom in a little farther. See how we're starting to get some nebulosity here? Now this is just after 4 minutes, but I wanted to switch over to another view that you might have seen recently. It is from the James Webb Space Telescope, the JWST, and what is really interesting is that this view is a mosaic, probably the biggest astronomical mosaic ever made, and certainly the closest view ever seen via infrared. And what is interesting about these galaxies is that you can see them kind of in the close-up form, the way they're interacting. Look at the way this galaxy has kind of had a little bit of a torn-up collision with another galaxy. The Quintet are these 5 galaxies pictured together here, and it is apparently featured in the holiday classic film It's a Wonderful Life. I think it's at the beginning when the angel is supposedly speaking, and a little picture of these 5 galaxies lights up as the angel speaks, I believe. But this is 150 million pixels, and it's constructed of 1,000 different imaging files that JWST has captured. You can see, of course, all these sweeping tails of gas and dust and stars. And what we love about this site is, of course, it's the beginning of what we can really enjoy with the JWST telescope. Now, I know you're familiar with the JWST. You know, of course, that it is parked out there in orbit around the sun, just outside the effects of the Earth. And here's a timeline that explains the launch of JWST starting around Christmas time. Takes it all the way through today as we're videoing this, July 21st. And it's kind of exciting, isn't it, to see that the JWST is now performing exactly as astronomers hoped that it would. I'm going to just take a second and see if I can call up our... just to make sure we've got our audio, and we do. And just to look and see who's on here, I'm going to go back to our live image of the same part of the sky, of all those Stefan's Quintet galaxies. And perhaps you can see, boy, our color balance is having a hard time with this part of the sky for some reason, but you can start to see these galaxies that are beginning to form up here. I'm going to see if I can tune them up a little bit better. There we go. That's not bad. Maybe just a little too much red in there. There we go. That's a little better. And we'll run those blacks back down to here and then bring these mids in. So you can start to see our 11-inch RASA view of those same galaxies. I'm just looking to see who's on tonight. Dane, it's good to have you back. Good evening. I think if I remember right, you're from up there in Minnesota or something. Azray, good to have you on from Arizona. Dennis, I think you're out in Colorado. Good to have you back. Kimberly, good to have you on tonight. I forget where you're from, Kimberly. Maybe it's also Colorado. I can't remember if it's California. P. Lark, good to have you. Robert Chandler, how are you? All the way from over in the UK. So you're up kind of late, Bob. I think it's probably, what would it be, 3 in the morning there for you. Lisa, good to have you on from Indiana. And Jen, thank you so much for checking in from Atlanta. Wow, you guys are faithful friends. I think you can see a little more nebulosity now in this Stefan's or Stephen's Quintet, sorry. And here are the exact galaxies that we're viewing when we come over to the JWST view. Let me see if I can get back to these now. Let's see if we can find that. There you go. Interacting Galaxy Stefan's Quintet. Now this was just released July 12th. So literally, what is this now? I'm trying to figure out the 21st, right? So this was 9 days ago that this image was released. And the JWST will continue to release images throughout, really for 20 years to come, I bet. And look at all those diffraction spikes. Some people like the way those look, but that's, of course, an artifact of the way the JWST is constructed with all those hexagonal mirrors. Look at all the galaxies that are viewed. Every one of these little disc-shaped spirals. All these are different galaxies. Probably the closest infrared view ever seen. Look at all the gases and dust that's being formed. So this is a beautiful image. I just thought we ought to start with that. Dane, good to have you on. Seems too wholesome to say your name. Oh yeah. Yeah, we'll welcome the next guy as well. Yeah, I think you're right, Dane. We'll just leave that unspoken. But anyway, enjoy this view of the JWST. And now, what do you say we begin once again with our quest to be able to work our way through the Herschel 400, the list of deep space objects. You'll recall that we're using this book, Steve O'Meara's Herschel 400 Observing Guide. And what we do is we just pick out one of the pages. We're starting tonight in the 4th night that Steve O'Meara says we should observe from in the month of July. And let's go find this object NGC 6144. So what we do is we go over to our planetarium software, and we look at NGC 6144, and there it's found it. We're going to center on that and make sure it's going to be up and visible for us, and so far it looks like it is. You can see we use Starry Night Pro as our planetarium software, and as you see it kind of pan across the nighttime sky in this computerized version of the nighttime sky, you'll see it swirl over to the southern part of our sky and finally land on the constellation Scorpius. And you can see that's the place where we're going to be viewing tonight, Scorpius, and right there by that star, Antares, not that far from it. And we're going to look for NGC 6144. So what we'll do is we'll go up here and we'll slew to that object, so we'll let you watch our scope starting to switch around. That's a live view of the scope there on the left. Let's see, where would that be? Over there. That's a live view of our RASA. That's again a Celestron Roe Ackermann Schmidt astrograph. You can see how the roof has rolled completely off of that structure. And what the telescope is doing now is it's raising up those weights toward the west. So again, in the view that we're looking, the weights are on the left or the west. And now the scope is rotating back in our direction. Again, the camera, as we're viewing the scope, the camera is looking up toward the north. So the camera is pretty much aimed at the North Pole, so to speak. And you can see the telescope kind of whirring around. So this gives you a pretty good indication of where we're pointing up to the south above where the camera is located. And this picture here that you can see below me is also a live view. And you can see how the telescope is now completely over on its side in this equatorial mount. So let's go back to our live view of the of Sharp Cap, and we'll get back here in just a second, and I can already see that we need to stop the live stacking that we've been doing, and then we'll wait till that settles. While that's settling, we'll put in the name of this object, which is NGC 6144. NGC 6144. We'll also put it down here in our title here. This is NGC 6144. And let's open up a, I'm going to open up an information screen about this. This is a globular cluster, and it's in the Scorpius, constellation Scorpius. So we're going to say a globular cluster in Scorpius. Okay, and then we'll switch back to the screen. And up here, we're going to now start our imaging run. And when we are observing, we're using the camera as our eyepiece. And what I like about that is you are able to observe with us. Even though you might be watching the YouTube stream, you are seeing almost exactly what I'm seeing here. You know what we should do before we start live stacking, though, is we should stop live stacking. We should make sure we do another plate solve just to make sure that we're centered on the part of the sky where we want to be. And remember, that's probably Antares right there. Look how it looks like Mars. Antares probably, I think, actually means that, Mars-like or whatever. So when we do this plate solve, remember, if you've watched the channel before, you know that we're comparing the live view of the scope with views that the mount has in its memory banks. And we were about 3/4 of a degree off, and that's like I've said before, that's the way we start the night. So, you know, you saw Antares there sliding a little bit off to the left. And now we're going to be centered directly on NGC 6144. So that's one advantage of doing that plate solve. And you know, you can see here under Tools, if we go to Deep Sky Annotation, it'll show you where 6144 should be, and it's thinking that it'll be over here. We'll see if that's where it shows up. So take that Deep Sky Annotation off, and we'll start our live stack again. Start imaging. We do about 20 seconds usually, 20-second exposures, and that's at a gain of 100. 100 is a pretty good sweet spot for this ZWO ASI2600MC Pro camera. At 100, it can display around 14 different f-stops, so pretty good dynamic. And right there it is in the middle of our screen. You can already see it from the very first 20-second exposure. You can see that globular cluster that is NGC 6144. Now, even though this is a part of the Herschel 400 list, which is kind of an advanced list, it's a step harder than the Messier list of deep space objects. You can see right away that beautiful globular cluster right there. We'll go ahead and color balance here, do a white balance, and see if we can tune this up a little bit. We'll bring these blacks up, make the sky a little bit darker, and that'll increase the contrast between that globular cluster and the night sky. And maybe we'll bring up our mids a little bit just to make sure we're picking up all the little parts of this globular cluster. Let's zoom in a little bit, but I kind of like the idea of having Antares up there in the upper left. See what you guys think. Lisa Cox says, beautiful. Mike, Jerry, good to have you aboard from out there in Death Valley. Salty Mexican, good to have you with us as well. I wonder if you're from Saltillo, maybe. Jen, quick question. Can we see the comet in the sky now? Been rainy here. Yes, we've actually viewed that comet before. If you like, we can take a look at that. If you don't mind, remind me of the designation of that comet, and we'll look at that in a minute. Thanks for asking that, Jen. Kimberly says, men are from Mars, I live in Venus. That's awesome, Kimberly. About 114 degrees. Dennis, is that Fahrenheit? 114. That's really hot. But the humidity is let up, so it's not so bad. So it's a dry heat, you're going to tell us. 114 is still hot. Dennis is only 99 in Colorado today. Jen wanted to know if it's hot where Robert is, and Bob answered, it has been, but now the nights are cooler, Bob says. Back down to normal UK summer weather. Highs in the upper 20 centigrade, which would be, what, 21 is around 72. And so if it's in upper 20s, it might be in the upper 80s in Fahrenheit, rather than the 40 degree Celsius that they've been having, and that's enough to cook you, Bob. Jen says, oh good, that's definitely some relief. Bob says, like everyone, hoping the image has also been cloudy at night. Rats. Mike says, what filter are you using? The halo around Antares. Yeah, this is the Celestron light pollution filter that's made specifically with the RASA 11 in mind. And so it filters out a lot of the light pollution, that we would see here on the edge of Louisville if it weren't for that filter. And we just run that one filter all the time. It's just not worth taking it out. I've tried it before, and the whole sky just floods with artificial light if you take it out. Put it in, and we can get rid of a lot of the light pollution, thankfully. Papa Tech, good to have you aboard from Florida. Looks like you've got 81 degrees. And Stu, good to have you from New Zealand. Just 60 down there. Ryan makes videos. It's the first time I remember seeing you here, Ryan, I think. From Maryland, clear skies and warm. You've got your setup capturing 3 asteroids. Awesome. For the MPC. And then on to IC5070, the Pelican Nebula. The nights are so short. They are, aren't they? You have to pretty much start at 11 o'clock here to get true astro dark. Pier-Tech Clear Skies. You're on IC1369. Nice, Pier-Tech. Azray, it's 114 in Arizona with the wind. It feels like you're in a blow dryer. So sorry. Jen's thankful that Robert's got some good views. So it's really great to have you guys here tonight. A couple of dozen people on the live stream. Welcome to everybody. If you haven't yet told us where you're from, that would be great. If you could just say, you know, I'm John and I'm observing tonight from, you know, St. Paul or wherever you are. Remember, you're observing right along with us. Well, this is 4 minutes and 40 seconds, and look how we're picking up this globular cluster. This is NGC 6144. And we're going to do an observation here. We're going to associate it with the Herschel 400 list. And we're going to say that tonight's session is what? Is it, what is tonight's session? Is it 76? Well, look, the date's wrong there. This is July 10th, and this is July 21st. Let's see, can we sort those? See if we can sort those so that we can see what session to choose. I don't know if it's letting us sort them. Tell you what, before we set that, we're going to go up here in the observation sessions list. It's 77, yeah. So we're looking for, tonight is the 77th night we've observed. Let's try one more time and let it whir a little bit longer. There we go, 77. So we're going to associate it with that observing night. And then in our notes, we're going to say, let's get back to our live view. NGC 6144 was looking great from the first 20-second exposure. But after 6 minutes, we could make out, what do you suppose there are? At least, would you say 100 stars? This is this strange behavior that happens here. The first time or so, sometimes more than the first time, that we use Starry Night Pro, it kind of misbehaves. There we go. We can make out at least, let's go back here to the live view, at least 100 or so stars in this globular, in this glob near Antares. So just making some kind of an observation there so we can remember what we looked at. This is our first time ever to observe NGC 6144. What does this globular cluster look like to you? I mean, sometimes I see, look at the way we're seeing some yellows in there. Do you guys see that? Let's look at our color balance again and see if we can make sure we're getting this as best we can. Is it just my imagination, or are we seeing a lot of yellows there? What do you guys think? A couple of brighter stars. This could be a foreground star here. But look at all those yellows. And I think one of the reasons why is because the yellow stars, this is a cluster of stars that are traveling together, and they're older. So these yellow stars are probably older, and who knows what the age is. See if it says here in the general info. Some of them are up to 15 billion years old. Yeah, that would be pretty old, wouldn't it? I'm going to look here and see if we've got any other observations here from the folks in the live stream. 3 p.m. for Stu down in New Zealand. No stars for him. That's why he's here. Good to have you here, Stu. We're glad. Jen actually thinks you're lucky, though, to be in New Zealand, the home of some great movies. Jorge Calderón, bienvenido de Perú. Podría ser de Lima o Trujillo, no sé dónde. Jen is greeting Jorge. Bob says, Jen, I believe that you have to image with a long exposure to see the tail, unlike Comet Neowise. Jorge says hello. Look how bright that cluster is. Cool, she spells cool, K-E-W-L. That's a cool spelling. Kelly, good to have you here from San Antonio. All right, so we're going to save an image exactly as seen of this globular cluster. And then we're going to go over here in Stephen James O'Meara's book and just see what he says about it. He says, it's a beautiful 5-minute wide circular glow, somewhat concentrated. It's easy to see with averted vision. Well, we don't have to use averted vision, looking away from the object and then trying to see it with our peripheral. If you're going to ignore the glare from Alpha Scorpii, which I think is Antares, isn't it? At 101 power, the cluster starts to resolve, especially around the edges. It shows a slightly brighter core that has no really central condensation. Okay, so that's what he says. Then what we do is we put a check mark in here just to show that we saw this. By the way, 6171 is our next object. Another thing I've been doing is I'll go here and I'll just put a 1 here in this spreadsheet, and that just helps us keep things straight. Now in our, I know you guys are going to think, wow, this is a lot of hopping around, but we do it nonetheless. We add the object to the list of H400 observed, and then another thing we do is we go up here and we go to Live Sky, and in Live Sky we actually log in to the simulation curriculum site, where the simulation curriculum people let you keep a real-time view of your lists that you're observing from. And we're going to go to the working list and we're going to search for NG6144, and we're going to remove NGC6144. There it is. We're going to remove 6144 from our working list. And that way we know it's observed and we can keep a real-time view of how we're doing. We have 374 entries yet, 374 objects to observe in the Herschel 400 list. So we have a ways to go, gang. But that's kind of the way we keep track of a running total of where we are. So this one is done. And let's go now to NGC 6171. NGC 6171, NGC 6171, and there it is. Let's center on that. While that's centering, let's go back to SharpCap, which is the imaging software we're using here, and let's stop the live stacking just so it's a little bit cleaner. And over here in our planetarium software, let's slew over to NG6171, and you'll see the scope move a little bit, but not too much. What Stephen James O'Meara has done when he created this list is make it so you don't have to move too much from one object to the next when you're observing on one night. So now we're looking at NGC 6171. Let's change our title in SharpCap. NGC 6171. That'll name the picture properly. And then let's change our title in the 6171. And we just do this for people that are stopping in. It's a globular cluster again. And it is in, are we still in Scorpius? No, we're in Ophiuchus. Globular cluster in Ophiuchus. Ophiuchus. Is that the water bearer? I'm having a hard time remembering Ophiuchus. So we now can do our plate solve again. Make sure we're in the right ballpark of the sky. I think I can already see it right there in the middle. even with just these 3-second exposures that we do when we're targeting, we can already make out this globular cluster. It must be pretty bright. Let's see if it has another. Yeah, it's M107. So NGC 6171 is also known now as M107. You might remember that the Messier list was assembled by Charles Messier when he was looking for comets, and he would make a list of the objects that got in his way and distracted him. Now we're just 8/100ths off on our searching, so not very much. So let's take our sequencer and go to start imaging, and boy, you can already see that was just a quick glance at the last target that we had been looking at. But now we're going to see this globular cluster, M107. And these objects that are above 100 in the Messier list, they actually were in Messier's notes, but he never published them. And it was researchers. Oh my goodness, look how beautiful this globular cluster is. My goodness, is that not lovely and bright or what? Wow, that looks like something you would see on the Champs-Élysées of Paris, France during Christmas time. And these are some beautiful cafe lit up with a lot of Christmas lights or something. Look at that bright core, just really dense. I don't know if we have to do any color matching of this, but we'll try. It already looks pretty good. Let's move our darks a little bit over, and that'll let us pick up a few more objects. And then we'll bring our mids up a little. And while that's forming up, let's just catch up with our live stream here. Let's see. Kelly's from San Antonio. We are glad you're here, Kelly. We're glad you're catching up here. Jen, thank you for being like our greeter. Jen's kind of like the Miss Congeniality greeter person for us. And Jen, we appreciate that. Jorge says, muy cerca de Lima. So good to have you here, Jorge, from Lima, Peru. Wow, that's awesome. Kelly says hi to Jen. Jorge says he lives on a farm. Wow, I bet you've got some darker skies than what they would have if you were right in Lima. Kelly says no, but it's terrible skies. Sorry to hear that. Kimberly's from Venus, Florida. Good to have you here, Kimberly. I remember now. Jen says a good friend in Fort Worth. Stu says, sorry, I'm here because you're marvelous. I don't know who you're talking to there, Stu, but whomever you're encouraging, it means a lot. Azray, the comment you're asking about, okay, so let's remember that designation, C/2017 K2 Pan-STARRS. Yeah, I remember we went to him before. Jen Azray, is that what he needs to find it? Yes. May not be visible currently from Emerald Hills. Rats. Bob, sorry to hear that. Jen, Doug, do you have this in the winter? Yes, we run all year long. Yes, we do, because that list of 400 is long. Yeah, exactly. That's why we observe from inside, so that we can observe all year long and not even blink. The observatory, outside, the observatory gets cold out there with the sky open, but we're observing from inside here. It's nice and comfortable. Dane says, tardigrade is water bearer. I bet that's Ophiuchus is the water bearer, yes. Azray says he thinks so. Jen, wow. Kelly says, oh, that's pretty. Dennis, isn't this also called a crucifix cluster? Wow, I wonder. I bet you're right. Let's see what Stephen James Ramirez says about it. He says at 23 power, NGC 6171 appears as a 5-minute wide sparkling glow with a weakly condensed core. With averted vision, the cluster is elongated east to west. And has at least 4 11th magnitude stars around it in the form of a crucifix. So there you go. I think you're right, Dennis. I think it is the crucifix cluster. I think I might be able to see those. Can you guys make that out? Look. Here's the main part of the cross, and this must be the part of the cross. It's like the cross beam. Wow, that's awesome. At 72 power and 101 power, the cluster's outlying stars stand out boldly against hazy wisps of light that look like ruffled hair. Ruffled hair. See if we can see a little more of those hazy wisps of light. I don't know if we're getting those hazy wisps of light yet. What do you guys think? Of course, we've only been exposing for 4 minutes, but if Stephen James O'Meara could see them live in his 4-inch telescope, then we have to assume that we'll see something with 4 minutes of exposure in our 11-inch telescope. You think the hazy wisps are just barely visible in the background there? Steve O'Meara, you amaze me at what you see. The cluster's core is a boxy, patchy, marred with dark lanes. Okay. So there you go, M107. I'm going to check that so we know it's done. And then let's do our observation of this. Looks like we were here on April 1st. So we'll do a new observation. And you notice how it keeps the observing list and it keeps the observing session. And we'll just say this cluster, this globular cluster, is much brighter than most of the Herschel list. And it's also known as M107, accordingly. The Crucifix cluster. Wow. Very cool. All right, let's save exactly a scene here. And we'll just look one more time at the stream. How are you getting along with the RASA 11 as opposed to the RASA 8? Bob, I would say that the RASA 11 seems to gather light maybe by a multiple of, I'm not doing this quantitatively, but I would say it's a half dozen times. It's probably 6 times faster. It feels like. It's very quick. Jorge, Bortle 4 skies there. Okay, we're about Bortle 6. Dane says, Dennis, it's interesting. I did see 2 right angles at the top. Jen, me too. Jen says, beautiful. Kimberly, very pretty. You guys are awesome. I wonder if Copernicus was cut or uncut. Dennis, Dane Christensen, it's always amazing what we can see out there. Amen. Jen, so did this guy discover all 400 of these and name them? Actually, that's so good that you asked that, Jen. Herschel actually discovered about 2,500 of these deep space objects, and he just named them, with number designators. And it's very hard. His designators are not very clear to me. For instance, his designator of this object might be, it's not noted in Sky Safari, but Stephen James O'Meara will have it. He called this, and I said he would, he called it H and then Roman numeral 6-40. Not as picturesque, Mr. Herschel. But out of the 2,500, it was actually an astronomy club in Florida, the St. Augustine Ancient Skies, something or other. St. Augustine. Why do I have such a hard time remembering that club? St. Augustine Ancient City Astronomy Club, the ACAC, in St. Augustine, Florida, who curated about 400 of his 2,500 and sent this into Sky and Telescope back in, like, what? Is it 1996 or something? They sent that in? Oh, sorry, 1976. And this thing caught on really rapidly. So over the 20 years, it grew in popularity. And by the mid-90s, the Herschel 400 list was really a thing. So actually, it was that astronomy club in Florida that picked the 400, not Herschel. Herschel discovered 2500 to his credit. That's amazing, isn't it? And he was working when? Somebody help me remember. Was Herschel working in the late 1700s? Is that when he was observing? Well, it just says 18th century. Yeah, so late 1700s. All right, so we're going to save this one more time since we accumulated a couple extra minutes there, 9 minutes. And then we're going to go to the next sequence. That's a beautiful little cluster though, isn't it? So beautiful. And the next one that Steve O'Meara has us visiting is NGC 6356. NGC, so first we go here, NGC 6356. Oh, you know what? We didn't mark in 6171. We need to put that in observed. Observed, and then we need to go over to Live Sky and search for it here, 6171. Do you think we had actually already visited 6171 before? Because it doesn't appear to be in there. H400 working list. Edit 6171. It's gone already. So we had already observed this. Let's go over to our spreadsheet. Yes, right there it is, but it doesn't show that we had observed it. Let's go back one more time and look at our observations. Just curious now. We'd observed it on April 1st, but not as a part of this swing. So I bet we were counting it because we were there April 1st. But that's because I think this is also a part, isn't it? Isn't this a part of the, well, the Messier list, of course. So that's probably why we counted it. But we need to observe it again as a part of the Herschel list. So that's done now. And did we save this? Okay. Now, the next object we were going to, I've already forgotten the number, is 6356. NGC 6356. GC. Oh, before we go to that, let's go to that comet. Let's see if we can get this comet first. I'm looking again for the designator C/2017 K2 Pan-STARRS. Now, if I remember right, there's a problem finding this. C/2017. Nope, right there it is. But that's AB5. What if we look for it by saying K2? No. There is a problem finding this comet. C/2017 K2. There it is. So we're going to center on it here. It is acting like it's above the horizon. Look at that. Wow. And then we're going to go to slew to it. So there's the scope responding to the slew command. Wasn't too far away from where we were. Let's open up the little info window about it. Yeah, we were here on June 18th. Now let's go to here in SharpCap and change the name to C/2017 K2. And let's go down here in the title and put that this is C/2017 K2 Comet. And go back to screen before I forget. I generally always forget. Let's do a plate solve just to make sure we're not looking in the wrong place. There is a fuzzy patch right there in the middle. You can already see it, huh? Fascinating that it's that bright that we can see it with the 3-second image. Of course, we're at gain 400. In these 3-second quick shots for targeting, we're at gain 400 on our ZWO ASI2600MC Pro. 4/100ths of degrees. So let's don't fool with plate solving anymore. But it did settle it nonetheless at 4/100ths of a degree, and that does make the mount more accurate when we go look at other things. See how you can already see it right there in the middle? I hope you can make that out. We're going to let the mount settle just a touch longer. Okay, that's probably long enough. And then let's go to the start imaging. You notice how it has that last image in its RAM, so to speak, so that when we start imaging, the first thing you see is that the old record of the image we were looking at. Jen says, whoa. That's Jen saying whoa at the 2500 objects. No kidding, Jen. Indeed. There it is, right away. Hi, Doug. Just stopping by to thumbs up the stream. Love the globular cluster. Don, thanks so much. By the way, if you like this kind of content, Don is reminding us, if you wouldn't mind clicking a thumbs up, it does get the content up in other people's dashboards so they can find it. Jen greets Don. Thank you so much, Jen. Azray, thanks for the background info. Jen, thank you for the explanation. It's amazing. Bob, yes, same time as Messier. Jen says, Azray, seems back in those days they did a lot of stargazing. Do people do that much now, like what this guy did? You know what? I'll just jump in with your question, Jen. People do a lot of stargazing now, but a lot of the discoveries are made by all-sky surveys done with robotically controlled scopes that are wide field, and they are in places like the mountains of Chile and the Mauna Kea, whatever that's called in Hawaii. A lot of those kinds of things are making these kinds of discoveries. Yeah, Don says people that hunt for comets do. Jen says, that's it. Wow, yes. Simon, hi from Perth. Good to have you aboard, Simon. Glad you're back. Bob, Jen, the other difference is that those astronomers, that's right, they were drawing by hand what they saw. Now it's EAA. We only need 30 seconds, and we can already see in Doug's stream. Right, Bob. Don, well, I'm off to record another Opal video. Wow, good luck with that. Jen, this is so interesting to me, Bob. Jen says, hey, Simon from Perth, and she asked about the weather there. Simon says, no, lots of rain. Rats. Sorry about that. Bob says, every year Doug does the Messier Challenge to see if we can see all 110 objects in 24 hours. That's right. And Bob, you're always so good to pitch in on that. Dane says, have you already observed NGC 6369 from Herschel 400? I wish your Excel sheet was public so I could see what you've already done and what you're planning for the evening. Wow, Dane, that's a great idea. You know what, Dane? We'll try to do that. We'll figure out a way to make that public. I'm glad you asked that. What a great idea. I'm going to go to my to-do list. Rats, I lost my place here. I'm going to open this back up so I can, there we go. I'm going to go to my to-do list and say public spreadsheet of Herschel 400. It's a great idea. Dane, thanks. Fair point, Dane. Yeah, I think that's a good idea. You know, we can go back to the spreadsheet and look. Have we observed 6369? Doesn't look like we have here. Then we can also go to Live Sky and search here for 6369. We have not. See, it's still in our working list, planetary nebula. So we have not observed that yet. Okay, so back to this comet. Let's see if we can tune this up a little bit. First, let's do a better color balance. That's actually not bad. Let's scoot our blacks over here. Too much. Bring our mids in a little bit. Let's increase that contrast between the dark sky and the comet. Isn't that fascinating, the way the Comet appears so big? Of course, we're zoomed in. Here is the native frame of the RASA 11. But look how big that Comet is in our view. That is huge. Of course, if I remember right, this comet just, I mean, literally just a night or two ago, it passed the closest that it's going to pass to the Earth, right? I think what do you call that? The closest brush that we're going to have with this comet. I think there's a name for that, but I've forgotten the term. It came the closest to Earth that it's going to be. Let's put this observation box over here and go back here and see what they say. It's a comet. Oh, this is just general stuff. It doesn't say much in particular about this comet. Look how it's moving so quickly. So we'll say here, I need to take it away from this list though. Boy, how do you just take it off of something? I want to, oh, there's an X, yeah. I want to just delete that. There we go. And it's still a part of our observing session, but it's not a part of that observing list. We stopped by to see, now we'll go back over here, to see C2017 K2 at the request of, who was it, Dane? No. I forget whose idea this was. Who asked if we could come and see this? Asray, or maybe it was Jen. Jen, I think it might have been you who said, hey, have you seen that comet? You guys will remember better than I. Who asked for that? Elephant Trunk Nebula, 5 weeks of rain and clouds. Closest approach. Yes, Simon. Yep, it was you, Jen. Okay. Doug is about expanding people's knowledge of what we can see from our light polluted backyards. Check his other videos as well. That's easy astronomy as Doug does all the hard work. Bob, you're very kind to encourage. At the request of Jen, 0714, it was downright shocking how huge the coma or head was. Oh my goodness, we gotta go delete this entry. That's the craziest thing ever. So now we add a new one. We have to delete that. Come back here and paste that back in. And then say the head. shocking how huge the coma or head was. We could see a tail, but it wasn't very long comparatively. You know, compared to the classic comet tail, like look here in the Sky Safari view, that's like the classic comet tail, huh? And this tail isn't that long, at least tonight, at 8 minutes of exposure. Can make it a little bit longer by expanding what the sky. Let's zoom in a little more and expand pull the mids up. But still, it's actually not very long as comets go, is it? Well, that's a little bit longer. I bet if we stayed on it for additional minutes, that tail would keep expanding. Man, look at that bright core. Look at that incredibly bright snowball in the middle of that head there, that coma. Wow. We're going to save this now as seen. Jim, this is a good idea that you asked us to stop by here. Thanks for doing this. I know it's, you know, a little diversion from the Herschel list, but it's well worth it. Thank you for asking. Because these comets are amazing. Now, back to where we were going to go. Let's stop our live stacking and go to the next target. And now we're going to go to NGC 6356. NGC 6356. Here we go. So we're going to center on that. And oh wow, this is right there in the middle of the Milky Way. That's going to be beautiful, I bet. 6356. And now let's slew there. Slew over there. Kelly says, have you ever pointed the telescope at the moon landing sites? Yes, but you know, it takes such a huge focal length telescope to get even close. I mean, with this RASA, which is a pretty wide field telescope, you know, you can't really narrow down and see the moon landing sites to speak of at all. It's a good question, though. We have had that question before. Wow, looky there. You can already see that globular cluster in the middle. Isn't that beautiful? And that's a 3-second exposure. Let's go ahead and do this just a little bit at 20 seconds, but it won't take too many, will it? Before we can start to make this out. Yes, it was the tail. I do when it's full moon time. The moonlight blocks everything. Yes. Dane, is it true that the tail is not a good indicator of the direction? That's right, Dane, because the tail, look at that, because the tail is actually a phenomenon resulting from the effect of the sun on the ice particles. And as I understand it, it's actually a combination of something, you could think of it as akin to the solar wind. You know, these photons that the sun is pushing out, it does have a tiny bit of pressure, and there's also an ionic, is that right? An electromagnetic force from the sun, which ionizes the tail in a polarized fashion, so the tail is pointing away from the source of the electromagnetic radiation. So the tail is not a result of traveling through some kind of atmosphere like the tail on a meteor, because there is no atmosphere in space, so there's no drag, nothing causes those ice flakes to peel off except for the solar wind, the electromagnetic radiation from the sun, and just the effects of those photons pushing on the ice particles. Sometimes you'll see two tails, and the other tail might be a reaction from, say, a planet that the comet is passing, as well as a little bit of the direction. You know, you can pick up sometimes a little bit of the direction as well. Check it out, beautiful. What's that bright spot? That's the core of the coma, the sort of center of the snowball. It indicates the solar wind. Yeah, Bob is filling us in. Azray looks great. Hey, Mike, I remember you. Dane, Bob. So this is a concept I have trouble grasping. If we see a comet's tail and we know where the sun is, can just those two factors determine direction? Bob says, as it moves, the solar wind changes the direction of the tail. So in a manner of speaking, you could determine the location of the sun and you could determine its direction, but it's also easier to plot the direction by its movement because it moves so quickly compared to the night sky. Kelly, glad to know I'm not the only one who would want to look. Jen, thanks for that request. Don says, great view. Bless you, Don, for encouraging. Mike wonders if he knows Jen. Could be. Bob, Dane, it's very hard. Some's involved with how everything is rotating. Good point, Bob. Boy, Bob, you can just go ahead and keep answering things there. We have about 31 on the live stream. If you haven't, documented where you're from, just jump in there, please, and say, I'm, George, and I'm observing from such and such. That's great to know where you're from. And if you're watching this as a recording, thank you for tuning in as a recording too. Okay. Let's see. Are we in our, we're in our imaging run now, aren't we? So let's do a new color balance. Wow, look at the core of this globular cluster. That is a bright core, isn't it? Wow, look at that. So this is NGC 6356. I'm going to go up here. NGC 6356. Thank you, Robin Glover, for allowing us to make that change after we had started the imaging run. NGC 6356. That's zoomed in at 131%. Let's back off at 100%. Boy, this is a very star-rich part of the night sky, isn't it? Look at that. Let's go ahead and see this in its context. Look at this cluster in the context of the night sky and this portion of the sky. It is so star-rich because we're in that Milky Way portion. This is NGC 6356. It has no other designator like Caldwell or Messier. It's in Ophiuchus. We've never observed this before. Now we want to go back to the Herschel 400 list as the source. And we want to say, well, there we go. This cluster, oh, I tell you what, this Starry Night Pro, you just gotta love it, don't you? This cluster delete. You're wondering what I'm doing. There's a glitch in Sky Safari, in Starry Night Pro. There we go. This glob is so bright. In the context of the rich star field behind it, it makes a beautiful view in a very rich part of the sky. Yeah, I'm looking forward to the day that simulation curriculum fixes this. And I have reported to them, and they've acknowledged that it's a bug, and they have said they're going to address it. And they kind of acted like they'd try to get it out this summer. I hope they do. 6356. So let's go read about this quickly. 6356. It's a bright and condensed, about 3 minutes across, appearing almost as prominent as M9. It has a tight core in a concentrated halo with averted vision, seems mottled. Mottled. Would you say this appears mottled? I don't know. Steve O'Meara, you amaze us with what you see. 6356. At 72 power, the cluster's core is not so condensed as it is soft. Like a comet that has lost its nucleus and is beginning to fade. With averted vision is mottled. The brightest stars in the cluster shine at 15th magnitude, but clumps of them condense to form a mottled haze. He's really into that word mottled on this object. And then he says, don't move your scope because the next object is nearby. 6356, we'll put a check mark there. And while we're thinking of it, let's see, we already did an observation. Let's go over here and say, add it to the list of observed. And in live sky, go to 6356 and delete from the working list, and then save. Look how rich that field is. Wow. So the next object that we're going to go to in a second is 6342. I wonder if that's in our view right now. Doesn't appear to be. Nope. Look, there's M9 just outside of our view. Okay, let's go back to here and save this as seen. Let's catch up with the stream and see what you guys have been saying. Jen, I've seen you on here before. Surely I have. P-Lark, eating a taco. Stu, can only see the telescope, not the view. Change the image, please. I must have already done that, I hope. Because I think you're seeing the view now. Mike, yes, last time watching from Georgia. Jen, yep, me too. Stu, thanks a lot. Bob, Kelly, Doug is right about the telescope, but you do see general details of the MAR, Latin for sea. Azra, you're on telescope view. Oh, you mean like, were we on scope cam? But we went back to screen cam, right? Doug changed if I had $1 for every star in that picture, I could afford a RASA 11. Dane. Dane, several RASAs, haha. What's the green line? That's a part of a movie, I think, that is on Netflix. I bet it was a hot pixel. No, that's a satellite. We got photobombed by a satellite. Jen, if this blows your mind, wait until you see the galaxies and nebulae, especially the colors. Dennis, Jen, that's Elon Musk. Jen, a live planetarium. Dennis, oh yeah, I'm not a big fan. Jen, really, Robert, I can't wait. Bob, Jen, watching on Abilene, so image not that big. It could have been a satellite, or if in a starry night, it could be equatorial lines. Yeah, it was a satellite for sure. Well, that's a beautiful globular cluster, isn't it? That's just gorgeous. This is a live view, don't forget. This is not something that's recorded and we're showing you an image of it. That's the actual view we're seeing outside from the observatory here right now. That's the actual view that you're seeing with me. We're seeing this live together of NGC 6356. Very cool. Next target up to bat is going to be 6342. Did we already do all our recording? I think we did. So let's go here and say 6342. And let's center there. Yeah, that didn't move very much at all. And let's slew there. Almost undetectable. Undetectable. Let's open up an info panel. So there you can see the movement of the scope. I think we can already see this right here in the middle. It's going to be another globular, I think. Right there. Now we'll go to the longer images. Change the name here to 6342, NGC 6342. And then we'll go down here on the title down here and change it to 6342, a globular cluster in, where is that? Ophiuchus again. In Ophiuchus. 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 All right, we're going to tune it up. Tune those colors a little better. Slide the black level, increase that contrast a little bit. Okay, let's catch up with the stream here. Stunning, Jen says. Lisa, is there a comet visible? I don't think it was a comet in that picture. It was a comet a while back. Bob, I had to put it on TV to see. I watched 3 hours of ugh, and my eyes were too tired for the phone, but I'm chatting on the phone. Dane says, kind of off topic, feel free to disregard. What are your favorite 3 movies about space? I don't know if I have any. Probably we'll see what you guys say in the stream. Bob says, Jen, that's the beauty of EAA, Electronically-assisted Astronomy. Be able to see these real time together. Lisa says, Mission to Mars, Star Trek, and Red Planet. That's a pretty good list. All right. Let's zoom in on this a little more. This is a very unique cluster, isn't it? That's 150%, so it's not going to be as clear. At 23 times in the 4-inch, NGC 6342 has a faint glow about 1 minute apart, 1 minute across, that requires averted vision to see well. At 72 power, the cluster appears slightly elongated north, northeast to south. Yeah, I can see that. Southwest with a roughly 12.5 magnitude star about 1 minute to the south-southwest. Okay, so that's 6342. So let's do an observation of this. Associate the observing list, Herschel 400 all, and the observing night is this 77. NGC 6342 stands out. Delete. NGC 6342 stands out. Associated with the Herschel 400 list. Even though it's only 1 minute across, it still stands out. We'll just go back here. And color-wise, it's more amber than blue, white. Cool. Just something there to remember it. Now we'll save exactly a scene. Catch up with you guys. Lost in Space, not the movie, but just Lost in Space. Mike Jerry likes Contact. Dane, I had to put on The Martian to fall asleep. That lasted about 6 months. Dane, Red Planet was really good though. P. Lark, Magellan TV has good space programs. Mike, Roxanne. You guys are... Mike Freyerberg says Roxanne is his favorite space movie. You guys are characters. This is only 4 minutes. It's already bright enough to save exactly a scene, and we can move on. So, next target. Okay, so that finishes with 6342. I believe that finishes this night. Let's be sure to remember to go over here and say add to the observed list. And let's see, I'm thinking sharp cap, we're done. All right, what's our next object? Target. I guess that moves us over here to the fifth night. It's NGC 6369. NGC 6369. Now that is a planetary nebula, so let's slew to that. You can see a little more movement in the scope, but still not much. It's still hanging around Scorpius there. Excuse me, my goodness, it must be getting late. 12:19. Don't Look Up was a great movie. Jen says, are those the real colors out in space? You know, color is sort of relative out in space. Yes, I am attempting to balance this according to its natural tendency, but even the color balance is not quite accurate, because if a nebula is more hydrogen illuminated, it'll be more reddish. Whereas if the nebula is more bluish, then maybe that's being made by sunlight cast through this certain kind of dust. So really colors are very relative in space. Basically you've got a certain star temperature, that makes a color, but aside from that, man, colors are so relevant, so irrelevant in a way, because it has to do with the kind of gases that are burning. But yes, we try to do a neutral color balance so we're seeing the colors as they really are, but I'm not sure we're very successful. NGC 6369. 6369. Okay, and then let's do our run of start imaging. And then let's see what Stephen James Ramirez says about 6369. Projected against the blackness of a dark nebula. Huh, that's interesting, isn't it? Barnard 77. So, as NGC 6369's nickname implies, it appears like a translucent spirit materializing in the darkness. It appears very stellar at low power, but swells with averted vision. With any moderate magnification, the nebula is a perfect opal, smooth, round, and well opalescent. The ring has a sharp interior that gradually dims outward. Is that still? Yeah. The central star, which shines at 16th magnitude, cannot be seen. It's all about 6369. I wonder if we've lost... Oh, it's a planetary nebula. No wonder. Look at this. You can even see the white star in the core. Let's try to make that a little bit darker sky to let that contrast. It's such a tiny planetary nebula, isn't it? So this is NGC 6369. A planetary nebula. And where is it? Is it in Ophiuchus? Yes, in Ophiuchus. Now, I know you guys that have been on the channel before, you remember that a planetary nebula isn't really related to a planet per se. This was gorgeous. Tonight after just 2 minutes. It's not really related to a planet, but when early astronomers would see it, they associated it with a planet, and so they wondered if it was some form of a planet, but it's not. It's a star that has gotten pretty big and then lost its engine and jettisoned off the outer layers, and then the engine restarted, and so it collapsed. And now it's illuminating the star from the inside out. And it's that sense of planetary nebula that causes this to be so beautiful. Look at these little prominences here sticking out. It's beautiful. Boy, that sky is just cooking up a storm there, isn't it? We'll try to make it darker. I think it's interesting the way you can see all that jettisoned out material being lit up by that inside star. Okay, let's catch up on the stream here. What's up, guys and gals? Jeff says. Jeff Horn, welcome. Good to have you aboard, Jeff. Dane, what did you say? You're doing 6369? Yes, that's right. 6369, right. Jen, Bob, was that a Saturday morning show, Lost in Space with Dinosaurs? Bob, it's mostly gas and the wavelengths of light. We see hydrogen as red, oxygen is blue, and yellow is sulfur. Asray, that's right, Bob, well done. Asray, glad you're doing this live stream. My skies have not been that good lately. I can't wait to be able to use my RASA again. Jen, well, it looks great to me, Doug. Woohoo! Thanks for the encouragement, Jen. Bob, with clever software, we can change the palette. Jen, I need a beginner's book. Bob, any suggestions? Asray, yes, Robert, I agree with you on the colors. Jen, hi, Jeff Horn. Bob, Jen, YouTube is your friend. Jeff, Doug, we are still seeing your live view. What? Yeah, I think we've just been staying in that. We've just been staying in that, Jeff. It's just a little bit easier because everything's all together in one place. Jen says we saw the comet. Jeff says, nice, Jen. Azra, Doug, you're on telescope view. Are we seriously? Because on my stream, that's telescope view, and this is screen view. I'm going to look at the live stream myself. Yeah, I think on my view of the stream, it looks like it's working okay. Tell me if I'm wrong, guys. It was cool. Who wants to tell me what a nebula is? Just a big cloud of dust, Jen, that's being lit up. Dane, shoot, I was hoping we could get more detail on this nebula. Jen, I was looking at the moon recently. I thought I saw a giant flying saucer. It was in fact a dust donut, the product of a dirty front lens and not being able to image for a while. Jesse, good to have you aboard, Jesse. Beautiful to us, terrifying to the locals. Bob, most of the images seen on social media, it's a product of many hours imaging and lots of post-processing. Right. Jen, it's good now. Just overlap in messages. I see. Thank you, Jeff. Bob, Doug is imaging for only a few minutes. Right. Yeah, I think this is the best we can do. I wish we'd see more detail here, but this is a very, very small planetary nebula. Very tiny. We're going to have to look up and see what width this is in the sky in terms of its angular size. But look, you can see, if you look very closely, you can see that little central star right in the middle of the planetary nebula. And that central star is what's lighting up the outside. This is only 30 arc seconds across. Only 30 arc seconds. Oh boy. Somebody, we're going to have to get simulation curriculum to fix this. Only 30 arc seconds wide. That's a very tiny object. 77. 63, 69. Save exactly a scene. Let's just go out real quick. Hubble, NGC 6369. Yep. Okay, so whoever that was that wished they'd see more detail, was that you, Dane? You're hoping you'd see more detail. This is the Hubble view of the planetary nebula that we're looking at right here. So the Hubble's got just a little bit better view, huh? Wow. Look at that central star. And it says right down here, 6369. That's amazing, isn't it? Some people call it the Ghost Nebula. the Little Ghost Nebula. Wow. It's beautiful detail, huh, from Hubble. Thank you, Hubble scientists. The Little Ghost Nebula. 5,000 light years away. Still impressed with the image. Bob, I love you too because I love music. Then I found Doug and met all of you. Then I figured out I could program a key fob for my car and remote for the garage door. Jen, you were just on a tech journey, aren't you? Asri, looks kind of like the Ring Nebula. Yes, it does. It looks very much like the Ring Nebula. Wait, a RASA 11 and the Hubble aren't the same specs. Dang. Lisa, fantastic, yep. Jen, so it was a dust donut on your lens, huh? Jesse Anderson, I wonder if any planets orbit in that cloud. That's a good question. I don't know if anybody's ever been able to observe the presence of any planets from planetary nebula because the sun inside of this planetary nebula did puff up and then shrunk. When it puffs up and it ejects this material, it creates all of this cloud that we have a hard time imaging through. That makes it tough to observe planets. But I will say this. If we can just go back for a moment, the JWST did just observe, I noticed, the JWST just observed water in the atmosphere of a planet around the object that it was observing. So it was observing an exoplanet that's labeled WASP 96b. And while it was observing this planet, it was able to do a spectrographic analysis of the atmospheric composition, and the signature for water showed up. So it does reveal the presence of water vapor. And we have a lot to look forward to as JWST continues to observe the atmospheres of these planets, because they might be some of the first planets that we should go visit to see if they have an atmosphere that's habitable. So I think that's pretty cool. Okay, save this as seen. Let's go here and say add it to the observed list of H4 unobserved. Let's go here, 6369. 6369, and remove it from the working list. Delete. And then save. Now let's go back here and stop live stacking. So next target. Oh, rats, I dropped my ink pen. Who knows where I'll have to go to find a new ink pen off camera here. Well, that's not good. I'm on the hunt for an ink pen. It's lost. The ink pen is gone. Oh boy. Well, we'll just visit this table over here and grab another one, and we'll worry about that later. I went on a treasure hunt for an ink pen. 6369, check. And Stephen James Ramirez said, oh, it's against the black of a dark nebula. That's neat. Bernard 77. Okay, let's go to 6401 now. 6401. NGC 6401. And so we're going to center on it. Oh, it's not visible. It's already set. That's sad, isn't it? 6401 is already set for the night. Well, I bet all these will be then. What about 6284? 6284. GC 6284. Center on that. No, that's set too. So now at this point, let's do lists. And let's go to the Herschel 400 working list and let it sort out the sky for us and figure out what's above the horizon. Dane, I fell for that line as well. Jen, no, not a techie, just driving. Found you in Astrobin. You should post your saved images there. I know, Azray, I should. It just takes time, and I just haven't done it. But you're right, I should do that. JWST sure was worth the wait. Right, Jesse. Amen. Bob, Jen, the other crazy thing is the amount of time it takes the light from the object to reach our eyes. Many tens of thousands, if not millions of years. It's possible the object may not be around anymore. AZ, is Astrobin full of cool stuff? You just go online? Don, if I recall correctly, that particular planet is a gas giant. Yes, that's likely. Okay, so let's go to NGC 3184. Dane, I know it's a week late, but happy birthday, Jen. Oh, 714. I'm still very confused on the light year thing. I think because I related to numbers, that's why I'm an English major and not a meteorologist. My birthday's not until October. So it's clearly, Jen did not make up her avatar by 0714 being July 14th. Jim, full of really nice images. You can find me there also. Dane, he thought it was her birthday. So Google Astrobin and join. Yeah, I'll do that. Bob, oops, I made that mistake as well. You guys are funny. Okay, so here we are at NGC 3184. So let's slew there. Uh-oh, are those clouds? Uh-oh, clouds in the background. That's not good. Look at the background. Let's go to, once we settle here, let's go to sky view. My goodness, look how much of a, we did a complete meridian flip. This is odd that it's saying 85 degrees here, isn't it? Oh, you know what? Look, this is not the right time. Somehow this got messed up. That's our problem. All right, let's go up here and fix our time first. Let's go in this menu and say now. Oh boy. That's funny. So somehow the timer got messed up in Starry Night Pro. Now let's go back to where we were. If you don't laugh, you cry. 6401. So now we're going to go to NGC 6401. Center. Yeah, that's more like it. So we are above the horizon, and we're back in that busy part of the night sky. So let's slew there. And we'll open up the info pane. here, let's there comes the scope. So you can see how this little crosshairs shows what the scope is pointing at, see? And then that's the sky view. Look at those clouds starting to float in. That's not good. So that's a live view of the sky. Oh, that's sad, isn't it? Well, anyway, we'll do our best here. So we should already be pointing at NGC 6401. Here in our imaging software, let's just do a quick plate solve to make sure that we didn't get mixed up, because we did 2 meridian flips in a row there. We just kind of want to make sure that we didn't make the mount go dizzy. Rainbow Valley, isn't Ophiuchus the 13th zodiac sign that is often overlooked? I'm not sure, Rainbow Valley. I'm not much of an astrologer. Jen, that number is part of my past, way past. Lisa, friends, I must take leave. Lisa out, leave transmission. Lisa, sorry, we'll miss you. Jen, I think I'm the oldest here. Have a great night. So you were born in AD 714. You guys are wild. Okay, so we were off 0.1 degrees. That's probably worth it. See, 2 meridian flips in a row. And now that that's done, let's go to Start Imaging. And here in our information panel, it's a globular cluster in Ophiuchus again. Yep, we can see it right there. Boy, that's a unique globular, isn't it? Very unique. Those reds are floating up high for some reason. This is what I was saying a while ago, Jen. All these colors are kind of relative. Trying to make that sky a little darker, but not too dark. Got to keep a little bit of the sky glow in there just to make it look realistic. Wow, isn't that something? This is NGC 6401. 6401. And let's go down here and say NGC 6401, a globular cluster in Ophiuchus. Look at those clouds coming in. Doug, have you ever tried CPWI program to control the scope? I did, Azray. CPWI is, if I remember right, wireless, right? But see, that would be hard for me because I'm 220 feet away from the scope. So I don't know that CPWI would help me as much. Bob, Jen, it's people like you that keep people like me interested in the hobby. I'm so happy to share. Jen, this morning I pulled up Emerald Hill Skies wondering when this was going to go live again, and into the takeover of the country's primetime, I got the notification. I was so happy. Jen, you're great. You're an encourager. Rainbow Valley, I have several photos of Ophiuchus. It sits above Sagittarius and Scorpius. Those 3 asterisms are the heart of Milky Way. Cool. That's good, Rainbow Valley, to put us in context. This is a very unique globular cluster. Let's open this up and see what Stephen James O'Meara says about it. 6401. It looks like a 5-minute wide knot in the Milky Way. Yep, that's a pretty good description. At 72 times, the cluster stands out as a slightly elongated, mottled haze. Its brightest stars shine at 15.5 magnitude, but clumps of them make the cluster appear partially resolved at 101 power. NGC 6401. Very, very interesting. 6401. 6401. Let's save a scene. Save exactly a scene. And then, there we go. There's the screen view for you guys. Let's put here 6401. Okay, that's already good. And then over here, let's say 722. Like a bright... Oh, this is acting up more than usual tonight. Associate with the observing list. Herschel 400 all. Like a bright knot in the Milky Way, said Steve O'Meara. 6401. And we're going to go back over to Live Sky and search for 6401 and remove that. And save. Let's go back here. Wow, that's really impressive with that star field, isn't it? And if you back way off, back to the native, you know, full resolution of the camera, just look at all those stars. We're right in the heart of the Milky Way. And look how there's a dark nebula right here, blocking out those gases. And then now look at here is NGC 6401. Wow. Of course, that's 250% resolution. It's amazing. All right, let's see what you guys are saying here. You're on telescope view. Telescope. We all start from the same position. Astrophotography was a COVID lockdown hobby. Stu, don't remind him. He won't see it till he's fixed it and fixed. Jen, really? You started during lockdown and know so much already? Wow. Right on, Stu. This is the Milky Way. Yes, the Milky Way, right. What do you mean by dark nebula? Dark nebula, it means it's like a cloud of darkness. And dark nebula, it could be that it's merely soot. So like, sort of like what you get when you burn a candle and the candle makes a black soot on the bottom of the tea kettle that you're boiling your water in with your candle. That soot, that could be the dark nebula, but it's not blocking the fact that maybe there's other kind of material in a dark nebula that we don't understand. We sort of know what dust looks like, and so we can spot dust lanes. But look how this is more than a dust lane. It's somehow pure darkness, and there should be stars there. Because see, the stars are probably, we reason the stars are consistent. But right here you can't see any stars. So we call that dark nebula, and man, if you add up all the dark nebula in the whole universe, it ends up being like 80% of the mass of the universe is in dark matter that we don't understand. And this dark soot is part of what's blocking these people as well. These stars as well. So really, most of the universe is made up of stuff that is darkness that we don't even understand yet. And it's blocking our view from the stuff behind it. That dust and that dark matter, we'll look forward to flying a spaceship to it someday to see what it is. Jen, you know more about garage remote controls than I do, so we're even. Ristion, or Carl Sagan would say, billions and billions of stars, right? I started learning astronomy with the lockdown as well. Cassiopeia got me into learning about the night sky and astrophotography. Jen, that's awesome, Rainbow Bob. Jen, you don't have to go to the expense of a telescope. Many night sky objects can be seen with a simple pair of binoculars. Dane, so is dark nebula a matter issue or a perspective from Earth issue? Like looking at the pillars of creation from a different angle. From the perspective of the Earth, we're seeing the patch of darkness that is equivalent to the silhouette of the dark cloud. And if we were to look at it from the angle of a different planet in a different galaxy, that cloud would be shaped differently, but it would still be the same cloud. I hope that helps. Astrophotography should have a government warning. This hobby will damage your wealth. It's a good point, for sure, Bob. Well, this is a beautiful globular cluster, even if it is somewhat small. Did we already remove it? We did, didn't we? From Live Sky. I think we did. And we already put it in the observing list here, right? No, we didn't. H400 observed. 6401. Now I'm wondering if we removed it from... Yes, we did. There it is. Okay, so let's save. All right, I think we have time for one more. And it looks like the last one we can do... We went to 6401, is 6284. So we're going to search for 6284 here, NGC 6284, center on it, still in that really super rich star field of the Milky Way, slew to it. Oh my goodness, look at all those clouds. Look at all those clouds. Let's look at the sky cam view. Oh my goodness, they're coming in, aren't they? Well, we're just 7 minutes away, so let's hope we can catch a part of the night sky here. And part of the night sky where there are not clouds. We're going to sequence, we're going to say go to the next target, just because that is an easy way to reset everything. And now let's reset it back to start imaging. Oh, I can see it right there. I can see it right in the middle. It's always amazing to me that with 3 seconds you can see these Herschel 400 list objects. Jen, I have my dad's binoculars. I very unexpectedly lost him January 2020, so I'm lost in this world, but I got all of his binoculars from his first set to the current ones. Well, Jen, we're sorry for your loss. We are so sorry about that. Don says, dark matter matters. For sure, Don. Jen liked that. Dane, oh man, Doug is going to bed. Worst part of the stream. Dane, you're so nice. Don, sorry to hear that, Jen. Glad you... Yep. Jen, he used to show me things in the skies I never knew about. Well, Jen, we miss him already. Rainbow, cloud's the #1 enemy of an astronomer. Right. Don, best part, they're highly useful in the daytime. Telescopes, not so much. Jen, thank you, Don. Yeah, it's those things that mean the most to me. Dane, #2 enemy is living in a big city with light pollution. Right you are, Dane. Look at this. You can already see that globular cluster there. And this is NGC 6284. NGC 6284. We'll go down here, by the way, and we'll say NGC 6284. And this globular cluster is in Ophiuchus as well. Ophiuchus does have his share of globular clusters, huh? Now let's go to the screen view and let's go to set this auto white balance deal a little better, because this is a mess. My goodness. You think this is because of our clouds? Somehow this became a royal mess. There we go. Somewhat better, huh? Look at all those stars. Wow. It makes me want to go play that Millions of Stars song, except then we'd violate some copyright violation. 6284. Been there, done that, right, gang? 6284. 23 power and a 4-inch. It's simply a dim, 2-minute wide diffused glow. At 72 power, the cluster appears round and has a slightly brighter core. Yep. The unresolved cluster swells a bit with the vertivision. Its horizontal branch stars shine at 16th magnitude. I'm going to put a check mark here. Next time, gang, by the time we come together, I hope we'll have, you know, a spreadsheet that you can see what we've viewed so far. I think that's a great idea that Dane had. We'll be watching for clear night skies. I want to just remind you, if you haven't subscribed yet and you're watching this, would you please do that, so that way you can be advised when we're doing content like this. Bright core, somewhat small though. First time we've observed this one too. If you want to see content like this more, you could do the thumbs up, and feel free to, you know, crash that bell so you'll be notified when content like this appears. I just want to one more time say thanks to all of you guys that come back for this. It's always an encouragement when you come back again and again. I really enjoy these live streams with you. It feels like we're kind of making a family here. We've got people that we see again and again, and that makes it really super interesting. Let's see, Bob says, Jim, the other thing to research, local astronomy groups. Now, what was the explanation for them being elongated? I think that the shape of the globular cluster looking elongated is just because of the way the stars are traveling together by their loose shape. And they look elongated because the cluster is a little bit longer than it is wide. Dane, Google Docs has something that is super similar to Excel. You can make it public but restrict it so only you can edit. Let me know if you want me to help you set it up and do custom filters. Dane, that's a great idea. We'll look at that. Bob, I live to the south of London with all that light pollution, but I'm still amazed at what I can see from my back garden. Good stuff, Bob. Jen, I'll do that, Robert. Thank you so much for everything tonight. Ristion, thank you for saying thanks. God bless you too. Mariana Ustarzo Hernandez, hey, how are you? It's good to have you, Mariana. So, one more time, I just want to say thanks to everybody who stops back by. The clouds are just now rolling in. We finished just in time. We do these about once a week. Whenever there's a clear night in Louisville, Kentucky, we will watch for clear skies, and we always send out an email to the email list that you can subscribe to by going to emeraldhillskies.com. There's a place where you can sign up there to be on the email list, or you can just subscribe to the YouTube channel and you'll get a notification in your list of YouTube things that come up in your YouTube searches. Not maybe quite as intentional as the email list if you use email, and many people still do. But you'll also get a community post, and then we also put a note on Facebook. Look for Emerald Hill Skies on Facebook. And so we're glad you're here. We're always thankful to God for making all these things for us to look and admire through the night. And thank you for being a part of these 2 hours that we came together here and kind of had a little community here while we were together. One last time, I'll just glance here and say Wow, Jen, so sorry again for that loss. Stu, thank you for your encouragement, loving these live streams. You say you'll be back if YouTube tells you about it. You're very kind. Jen, thank you for being back. You are so kind to come back and visit us each time, Jen. Wow. Dane, that's so nice of you to say that you would watch this every night. Wow, that's way beyond the call. Azray, so sorry you lost your parents as well. Jen, I hope you will subscribe to the email list. That's fun. Kimberly, thank you for being with us. Thanks to everybody. God bless and have a great night. That wraps it up for this live stream, but we hope you see you back on the next one. Take care. God bless and good night from Emerald Hill Skies. Take care.